I'm going to talk in the beginning of my talk about some of the issues that Otis Brayley and Laura Esserman, now Ned, has introduced to you. But first of all, I want you to think about your own language, English. I only have 2 of these idioms in Danish, in Scandinavian, but you have 5. Prevention is better than cure. An ounce of prevention is worth a pound of cure. It's not working. Better safe than sorry. A stitch in time saves 9, and an apple a day keeps the doctor away. This is what we are talking about. This is prevention, and screening is one of 3 kinds of prevention, at least, that has been defined. And when we stick to the language, we only talk about it as something beneficial. So this is why we also meet these emotional reactions when we talk about harms in prevention. And the harm I want to, this is not very sensitive, or it's too sensitive. The harm I'm going to talk about is not this kind of harm, where the doctor is afraid of a surrealistic apple, or it's eating the doctor, or it's thrown at the doctor. No, the harm I'm talking about today is this kind of harm, and this is also what the conference is about. And this is a woman screened in 95, 97, 99, and 2003. She skipped the biannual screening in 2001 and was diagnosed with an invasive breast cancer. And nothing really happened. I had this slide in 2003, and then we started the Danish lung cancer screening trial. And then in 2009, I had this slide. And this was new for me, that you actually, in such an aggressive cancer, can have a disease or a condition that doesn't really develop during 4 years. This was a male and diagnosed with lung cancer here. It's not really working well, this. Lisa, Stephen, and I we have published this paper, Overdiagnosis, how cancer screening can turn indolent pathology into illness. And this is another model that is confirming something about what Otis was talking about, and Laura was talking about, and Ned has talked about, but I will add one thing to it that hasn't really been raised. Here you have an abnormal cell. Here is the size where you can detect the cancer. Here is the size where it causes symptoms. And here is the size where you die from it. And from this model, it is a model, you can see different growth rates. And you can even see one of the cancers that has spontaneous remission. So from this you can see this is a person with an interval cancer, because it grows in between 2 screening rounds. These people are diagnosed and could benefit from cancer screening. This person is overdiagnosed because the person dies from competing risk, dies from other causes, and would never get symptoms. So this person is overdiagnosed. This person dies without knowing the person had cancer. But if there was an autopsy, we would find the cancer, and the person with the spontaneous remission is, of course, overdiagnosed. But let's say now that I increase competing risk of death. Just imagine lung cancer screening, how high the competing risk of death is among heavy smokers. I have to move my red line, and now C, D, and E are overdiagnosed. This has not been raised, and it's so important that you consider this. For instance, in PSA screening, a person that has an estimated lifespan that is very short is very likely to be overdiagnosed. I have borrowed this slide from Ross Harris. Ned said there was 3 different kinds of outcomes of true positives. I would actually say that there are 4. There's this group that can benefit from cancer screening. Then there's those that die anyway, despite the screening. Then there are those that survive anyway, the screening, and those that are overdiagnosed. So you have 4 true positive results. These have delay benefits, but in this cascade of screening, all these people can be harmed in so many different ways, and the harm is immediately. This is the group we are talking about. This is the overdiagnosed group, and if you want to read more about it, I would recommend you to read Ross Harris's paper about the taxonomy of harms of screening, and this is the group we are talking about, the overdiagnosed group. In this paper, Ross and colleagues have talked about a taxonomy of harms, because until then we were thinking about over-examination, over-treatment, overuse. But Ross and colleagues suggested a theoretical model where you could also categorize the harms into financial strain, hassles and inconveniences, medical cost, opportunity cost, physical harms, psychological harms, societal cost. And I and Lars Christian, a medical student who is here today, and Ross, we have added an eighth category, work-related costs. Can I have some, is that a water for me?
That was my water.
That's your water? Okay.
Look right behind you.
I'll skip it. I'll use my time better. If we take these categories, then, and we have done a systematic review on each 8 categories. Lars Christian presented it in this auditorium 2 days ago. And we only look at screening. We can find no empirical evidence for financial strain in screening. We can find it in other places, but not in screening. Thank you, Barry. If we look at hassles and inconveniences, it's the same story. We couldn't identify any empirical evidence in medical screening. We could find it in another setting in genetic screening, not screening, testing. Medical costs, we have seen that in hypercholesterolemia, that's a hard word for me as a Dane to say, lung cancer, and stenosis of the carotid. In lung cancer, we have done in the Danish lung cancer screening trial, which I have here on this slide, we have done one paper about costs. You have to be aware that we only had screening in one arm. The national lung cancer screening had thorax chest X-ray in the control arm. In the Danish arm, there was no contamination of the screening arm. This is a busy slide. We estimated costs in 12 outcomes by prevalence and quantity. From the prevalence and the quantity, we had a relative risk and a factor, and thereby calculated a cumulative effect. And the results that are up here, that I have enlarged here, shows that if you use the control group as a reference group, then you increase your cost by 10 among the true positives, by 66% among those false positives, and maybe you lower your cost among those with true negative results. It's an insignificant result. The problem about this study is that we explored our assumptions. We looked at the psychosocial consequences of lung cancer screening, and we had a baseline measurement before randomization. And we could see that in 3 out of 4 psychosocial outcomes, both groups were worse off. And those that were most worse off was the control group. So these graphs shows increased negative psychosocial consequences from first screening round to 5th screening round in 3 of 4 outcomes. So inviting people to a randomized control trial doesn't do any good. We also found substantial selection bias in the Danish lung cancer screening trial, both in relation to social demographics, but also in relation to psychosocial consequences. So now we had a problem, because the reference group that we used was the control group, and it was actually affected by being in the study. And therefore, we had this design that we invited average Danish people to complete a questionnaire and ask them how they were. I have enlarged this figure. So we asked a random sample of around 4,000 people to complete a questionnaire. 75% completed it. From this, 673 were eligible for lung cancer screening, and of those were 535 the same birth cohort as in the Danish lung cancer screening trial. So now we have created a new reference group, and from this, Manja has presented here at the conference our new estimates of costs, and as you can see, they were largely underestimated, because if you use a more true reference group, then the cost increase even in the control group, but 60% in the whole intervention group. We have also looked at overdiagnosis, and we have a paper coming out on mortality in the Danish lung cancer screening trial. We know from the national lung cancer screening trial in US that's 18.5% overdiagnosis, and this is screen-detected cancers. We know because it's contaminated with the chest X-ray. We know from the Mayo study that there was 51% overdiagnosis, but we also know from a more recent study there was 0% overdiagnosis. So we have calculated a best and a worst case scenario, 18 to 40% overdiagnosis. Remember, the Danish lung cancer screening trial had no screening in the control arm. Now you have the best and the worst case scenario. And now I want you to stand up. Now I will give you the number from 0 to 100%, and then you can sit down when you agree if you think the Danish lung cancer screening trial has 18% or 40% or less or more. So just sit down when I say the numbers. So we start with 0. Sorry, it goes fast. I will go back. So I think I will use this one. Okay, 10, 20, 30, 40, 50, 60. There's nearly no people left, so 70, 80, 90, 100. Okay, I'll give you the numbers now. This is how it looks. This is from randomization. This is the cumulative incidence. This is when screening, the first randomization started. We found 68 cancers at the end of screening in the intervention arm, 24 in the control arm, 96, 53 in average 5 years follow-up. That's 44 difference and 43 in difference. So if you want to calculate the screen-detected overdiagnosis, it's 43 divided by 68, and that is 63%. The strength is that we had no screening in the control arm. We have even looked at all our registers, how many in the control arm had a CT for diagnostic reasons, very low contamination. We have the participation bias I've already talked to you about. You could argue we have not taken lead time into account, but I don't know how you feel about this number. It's quite the same. And we have also found an uneven distribution in our randomization, so we have more heavy smokers, really severe heavy smokers in our intervention arm than the control arm. But the paper is coming soon, so we can discuss it there. Here you have the mortality curve. It's a bit hard to see. The black one is in the intervention, the gray arm is control, and you can see there's the same death rate, so no mortality reduction. I together with 2 PhD students, submitted this letter after the US Preventive Service Task Force recommendation. We called it a premature recommendation. I'm happy that I did it, and I can still say out loud, and I think US Preventive Service Task Force has been far too quick. We don't know the exact mortality reduction. We don't know how much overdiagnosis is. So how can you recommend something when you don't know the benefits and don't know the harms? If I go to opportunity cost, there are several screening programs where we have found empirical evidence for opportunity costs. Physical harm. Physical harm has been examined a lot in all kinds of cancer screening, aortic aneurysm screening, and carotid stenosis. Physical harm, psychological harms, the same, all kinds of cancer screening and other screening programs. This is my special field, and Alexander Barrett and Kirsten McCaffrey, who is also attending, and Ross Harris group. We have criticized a lot of these trials because there's no baseline measurement. Few are in a randomized design. There's inadequate measures, and there's very few with a long-term follow-up. If I take this example where I have shown that you get reassurance by going to mammography screening, this is a group that had screening offered. This is a group that did not have screening offered. This is at time 0. Then we implemented the national mammography screening program in Denmark during this time period, and then they felt more reassured, those that were not invited. But there was no baseline measurement, as Alex and Kirsten emphasized. And if you look again at our results, screening induces fear. So I don't see this as reassurance. I see this as relief from an induced fear. Tulia has a poster where she shows that overdiagnosis of carcinoma in situ might have the same consequences as invasive breast cancer. This is from a cohort of women we followed for 3 years after screening mammography. It has also been, it's up in the lobby. Societal costs, no empirical evidence identified. Work-related costs, there's this beautiful study by Sackett showing that screening for hypertension has work-related costs. So in my summary, I would say that physical and psychological harms are really proper investigated in quantity, but psychological harms are really not good science. I mean, the studies have a bunch of problems. We have very few studies on medical cost, opportunity cost, work-related costs, and down here we have not been able to identify any empirical evidence when it comes to medical screening. We did a systematic review published in BMJ in 2013, showing what is reported from the cancer screening trials. And as you can see, the benefits are reported, the harms are not reported. So even when we go to scientific trials, we can't find the evidence. Michaela Krag has presented this at an oral presentation at this conference. Here we have tried to estimate the degree of overdiagnosis in all cancer screening trials. We did a risk assessment, as you can see on the right, and the forest plot. And Michaela found a 21% overdiagnosis across all cancer screening programs. But those that are closest to the slide can see there's a huge heterogeneity in the estimates here. Only one trial had no bias. So poor quality trials again, and it's a problem when you want to estimate overdiagnosis. So my last slide here is a quote from Cochrane and Holland. It's from 1971. It says, if a patient asks a medical practitioner for help, the doctor does the best possible. The doctor is not responsible for defects in medical knowledge. If, however, the practitioner initiates screening procedures, the doctor is in a very different situation. The doctor should, in our view, have conclusive evidence that screening can alter the natural history of disease in a significant proportion of those screened. I think it's time to change this quote. I would like the last paragraph to say, the doctor should, in my view, have conclusive evidence that the benefits outweigh the harms in a significant proportions of those screened. Thank you.